Okay, so we're still inside of SQL, and we're going to live in SQL for a while. Probably take another quiz next time we meet, Friday. We haven't taken one this week, have we? Did we take one Monday? No, we didn't take one last time we met. So we need to take a quiz every single week, so we'll take one on Friday. I'll have appropriate queries in there that you can actually answer. Although we're getting to a point now where there's not many queries I could make where you couldn't answer them. We haven't actually talked about, there are some structures inside of SQL that you guys are used to in other programming languages, like condition statements and stuff like that. That kind of stuff exists inside of SQL. They also have cursors, which are SQL's equivalent to loops. And so SQL is actually a pretty complicated language. It has all of the basic constructs that you would need to do just about anything else you would do inside of a regular object-oriented programming language without the objects and without all of the helpful libraries to do stuff for you that you'd otherwise have to do manually. So we're going to stick with SQL for a while. Like I said, in this class, really getting an awesome introduction to SQL, and then after you leave this class, becoming a lot more familiar with it is probably the one thing that is going to help you the most to get a job later on. So having a command of SQL will help you infinitely. There are, there's places where you'll go where they'll actually test you on SQL. I know several of our former students who are now managers at different companies that I still keep in contact with have told me that they sit people down and give them a test on SQL to figure out how much they know before they hire a software developer, because they want the people that are strongest in SQL to be hired in the group. So it's extremely important that you have a command of the SQL language. So I'm not kidding. Do it, learn it, live it, love it. SQL's the best. Let's get into Management Studio and continue on. Oh, I can't wait to get the new machines in. I don't know if they've been shipped to us or not yet. Yes, image library. It definitely needs to be loaded. That's super important. I hate this machine. All right. Let's get logged in. And maybe I'll open one of the ones we've used before. Maybe I won't. Maybe I'll sit here and wait for it to open up a dialog box, because that's what I do on this machine. I wait. Okay, here we go. This is one, obviously, that we use. It really doesn't matter. I just want to write a stinking query. For when I've gone through this, we won't have to worry about it. Okay. Here's something. That's good stuff. All right. So we are going to continue our discussion of, everything. So SQL is a lot like any other programming language. Everything builds on what you learned before. So you may or may not need some of the different functions, clauses, keywords, whatever you want to call it, inside of SQL with every single query that you write. So far, we've dealt with a bunch of them, right? Aggregate functions and order and group, and we've messed with the in clause, having. We've dealt with subqueries, nested queries. We've talked about. We've talked about joins, but the only join that we've talked about so far is inner join. So remember, with an inner join in the on clause, where you're setting the equivalency for the join itself, the way that the result table is built is it says go out and find all of the rows where this particular attribute, this particular field inside of the on clause are exactly equivalent in both of the relations, right? So take business entity ID and match it with a business entity ID in another table, and if they match, give me the result. If they do not, then do not give me the result, right? So a really quick one, we're going to select everything from human resources.employee and inner join person dot business entity on employee dot business entity ID equals business entity business entity dot business entity ID, right? And we can execute this maybe. And I hate that it gives me this. Hold on. Okay, so the result of this is 290 rows, right? Because it's saying take all of the business entities that I find inside of employee, the employee table, and match them one-to-one with the business entity IDs that are inside of the business entity table, and then wherever they match, give me that result. So inside of inside of employee, there are 290 rows inside of there. Inside a business entity, there's like 20,000 or something, whatever it was, 20,000, whatever we've decided. And so obviously, the result here is going to be the lesser of the two, right? So all the ones that are inside of the table that has the least value, that's going to be the number of rows that you get back. Even so, let's flip this really quick. So right? So completely reversed it. And it doesn't make a difference, right? Because it's an absolute equivalency comparison. So this is equal to that. If it is not equal to that, do not include it. Doesn't matter where you put the tables, doesn't matter which side this is on or that is on. Now, if we were talking about some other, let me see. So tables, columns inside of employee and business entity. Oh goodness, okay. So not a lot there. What if I was messing with person dot, there's a person dot person, isn't there? Yeah, person dot person. Let's see, there shouldn't be anything here that I can match. But if we were matching on some other field, right, other than business entity ID, then it's a possibility that we would get a number of rows back in our result that would neither be the number of rows that are in either one of the tables, right? So maybe some exist in one and not in the other, and other ones exist in some and not in the other. Maybe they're repeated sometimes inside of there, and all that repetition that is inside of there is going to give you rows that are unique in their self, but match on that particular field that you're searching for. And so you're not always going to get, the result of an inner join is not always going to be the number of rows that are in the smallest table, right? It's going to be some number, whatever that is. The big thing to remember there is the match on the field that you're joining on is 1-to-1 per row inside of either one of the tables. It just so happens that this particular field in the one that we're dealing with is the primary key of both of the tables. And so obviously the result is going to be the one with the lesser number of rows inside of there, because it is a absolute unique value inside of both of the tables. But if we have some sort of value that's repeated, and we've seen that before, I can't remember what query it was that we ran before, but we saw before how you can execute a query and information like that might not, even business entity ID, right, can necessarily be repeated. I remember, yeah, it was pay history, right? So pay history, even though business entity ID is inside of there, it's repeated over and over because people's pay changes. So if we were to do, let me get this back, human resources dot employee, person dot business entity, let's do human resources dot employee pay history, and we'll do employee and employee pay history dot business entity ID. And for some reason I've got an extra dot out there. Right, there's 316 rows inside of there, so really quickly, obviously all these people inside of here should be employees, so you should be able to do the math really quick, 316 minus 290, and figure out how many repeated rows are inside of there. Those are people who their salary has changed in some way from the point where they got hired until now. And if you want to, you can get into specifics of that, but we don't really care. The point of everything that I've been saying is to understand how inner join works. It is an exact match, 1-to-1, on whatever field it is that you're putting inside of the on clause. Everybody cool with that? We're pretty good with grasping inner joins, because I'm going to move on. Any questions on inner joins, the way that they work, chaining them, anything like that?
So up until this point, inner join doesn't matter what order they are in this particular join. So when we go to the next few joins is when the order matters. Does that make sense? What's on
With an inner join, because it's a 1-to-1 match, the order doesn't make a difference, right? Because it's reciprocal both ways.
Right.
From here on out, with the next join I'm going to show you, this is when the order matters.
Yeah.
But you got to have to grasp on inner joins before you can understand the other.
Right. Okay.
And there are several others, but we're only going to talk about one because it's the only one that matters. So anybody else got any questions? Because I'm moving. Okay. All right, here we go. So we've talked about inner join ad nauseum. And so now we're going to talk about another type of join, and that is an outer join. So inner join, outer join. The outer join has 1, 2, 3 different variations. So there's a full outer join, there's a left outer join, and there's a right outer join. The only one we're going to talk about is the left outer join. Because a left and a right outer join are equivalent to each other, except for the way that you set up the on clause, right? So it literally means the thing on the right-hand side of the equivalency operator and the thing on the left-hand side of the equivalency operator. If you put something on the right with a right outer join, the thing on the right takes precedence. If you put something on the left in a left outer join, the thing on the left takes precedence. There's no point in having two of them. You just pick one, and the industry has picked left, and it just you just syntactically put everything on the left because it's equivalent to a right outer join with the opposite syntax, right? So left and right outer joins are equivalent to each other. It's just when you write a right outer join, you have to put the thing that you care about the most on the right of the equal sign, and when you write a left outer join, you have to put the thing you care about the most on the left of the equal sign. So because they're equivalent, we don't need both of them. We only need one. So just write left outer joins all the time, and just keep in your brain that the most important relation, important is in quotes, relation inside of that is the thing on the left-hand side of the equivalency operator. Example. What would be, we'll just use what we just got done using, right? So I'm going to select everything. Sometimes I think it would behoove me to not come up with all this stuff just on the fly, but I don't know. I've done it for so long, what the crap? Why not do it? So we're going to select everything from, what do we care about the most? We'll do human resources.employee. So we're going to select everything from human resources.employee. The syntax for a left outer join, you can say left outer join if you want to, but syntax is usually simplified to left join. All right, so left join. And let's do, what was it that we were using? Person.business-entity, was that what the name of it? Yeah. Person.business-entity. All right, so we're selecting everything from human resource.employee. We're left joining person.business-entity on employee.business-entity ID equal to business-entity.business-entity ID. Now, I'm going to execute this really quick, and then I'm going to start explaining. So the difference between this one and an inner join is not, right? There's no difference in the number of rows that we get back here. In fact, the data that we get back is exactly the same as well. So the way that the left outer join works is it says, take the things inside of the relation on the left of the equivalency operator and return all of them. And then take the relation on the right side of the equivalency operator and only return those values that match. Does that make sense? Give me everything from the left. Give me only the things from the right that match the things on the left. So, if we do the opposite of this, like that, what do you think I'm going to get back?
You're gonna get the entire person business, you're gonna get the entire business entity table, but there's gonna be some missing values.
I'm going to get the entire business entity table, all the data from it. I'm going to get how much of the employee table am I going to get?
Well, in this case, all of it, because
All of it? I'm going to get all of the all of the employee table? Okay. Why do we think we're going to get all of the employee table?
because
What?
it's a subset of the.
Right, because the employee, well,
In a way.
the business entity ID inside of the employee table is a subset of the business entity IDs that exist inside of the business entity table. Right, just by the name of it, the business entity table probably includes everything that has a business entity ID. And so if I can find a table that has a business entity ID, all of those things should be found inside of the business entity table. So I'm going to get everything from business entity and only those things from employee that match the things that are inside of business entity ID. So if I execute this, here's my information from, this is from employee. And then where's my stuff from business entity? Oh, it's got to be at the beginning. Oh, this is business entity, right? So business entity is person.business entity is 3 columns: business entity ID, row GUID, and modified date. So if I scroll down, keep going, I got a feeling it's around 290. Yep. So around 290, which is exactly how many rows are inside of the employee table, I start getting null values. Right? So it's trying to return data, the equivalent attributes that exist inside of the employee table. It's trying to return them because that's what I've asked for. I've asked for everything. It's trying to return them, looking for them, can't find them. It doesn't exist. It's just going to say, okay, I'll return you a column, but I'm going to give you null. Null means non-existent. This is the important distinction between empty and non-existent. Null means non-existent. The row doesn't exist inside of the table. So if I do a subset of that, let's say we want business entity dot business entity ID, and I want, I don't know, employee dot job title and employee dot login ID. And I execute that. Same thing. Eventually I get to null, right? Now all the null values should be what? What are the business entity IDs of null values that come from the employee table? So like my row 7,477, what kind of thing does that correspond to?
Non-employee.
Right, a business entity that is not an employee. Okay, so we keep track of stuff that isn't an employee. Kind of makes sense, right? Maybe we keep track of, I don't know, customers. People that we buy, third parties that we buy stuff from, right? I don't know exactly what we keep track of yet, but something, a lot of something. So, okay. What if I said, use this query to give me only the results that are not employees? Use this exact query, only give me the results that are not employees. what's true of all rows inside of here that are not employees? Guaranteed.
Job title and login into your null.
Yeah, right. Job title and login ID are null. So, let's use that to our advantage. Where, let's just pick one. Employee dot job title is null. And I get 20,487, which should be, what, 20,777 minus 290 is what it should be. So you guys okay with that? So, all right. What are we going to do? Oh, I got an idea. Let's go out to our last quiz that I gave you guys bad stuff on. Yeah, open it. All right, so I said this. Use a left join and person-to-person as the main relation. Give the first name, last name, and login ID of all employees who work in the Human Resources Department, person-to-person, human resources dot employee. That's a good one, actually. Okay, so let's build that sucker. You guys build it for me. How am I going to do that? We'll kind of double screen it here, right? So we're going to use a left join. Need a little more room on this one, but that's all right. There we go. Oh yeah, that'll be good. All right. Build this query for me. Select, yes. Excellent work. From what? Let's get some person-to-person. Okay, now inside of person-to-person, what are we going to grab that we need? We said we want first name, last name, and login ID. I think first name and last name come from person-to-person. So select person dot first name, person dot person dot last name, and then the other table we got to use a left join on. And what did I say? Human resources dot employee. And we're going to do employee dot, what'd I say? Login ID? Login ID. Okay, there we go. That's all I'm doing. Now you guys do the rest. So we've got our attributes, right? We've got our fields that we're pulling. We have the two relations that we're pulling from. And what I want is all employees, I want this information for all employees who work in the Human Resources Department. This is good stuff. So what do we want to do first? On, yes. Fantastic. We're on a roll. We're on a roll. Oh, that's good stuff. All right, what goes on the left?
Person.business.
Okay, so person dot business entity ID, and on the right would go employee dot business, not birth date.
We can flip that right now. I think
We could flip it.
yeah,
Sure, we
let's
could.
flip that. Yeah, I think that'd be better because we want to end up in the employee anyway. We just care about the employee.
Okay. What are my criteria? So we're using person-to-person as a main relation, so you're not allowed to.
Okay, never mind. Okay, let's keep it.
So one of the stipulations was you have to use person-to-person as the main relation. So I purposely made it more difficult. So what do we want to do now? Somebody online tell me something to do.
All in
Everyone logged out. That would be funny. All right, what do you want to do? How about we look at some data? What do you guys want to look at? This is an easy one.
their login ID or hire date.
All right, how about we just look at whatever the crap what we have written so far returns? How about
I
that?
accept that.
Yes, good. Phil accepts it, so that means we can do it. Let's do it. I put a breakpoint on it. Wrong button. Executed both of them. Again, bad. All right, here we go. We've got 19,972 rows. That's interesting, right? So at this point, we should have all of the rows from which table? Somebody online. Which table should we have all of the rows from?
Person, business.
Person to person, yes. That's what I'm talking about. So from the person relation, we should have all of the rows. So that means, looking at other data that we've looked at, there's only 19,972 rows inside of person to person, and there's 20,777 rows in person.business entity. So what does that mean? This is anecdotal. It has nothing to do with the query that we're doing right now. What is the discrepancy between person.person and person.business entity? No, that's person employee. That's human resources.employee and person.person and or person.business entity. Why is there a discrepancy between the number of rows inside a business entity and person?
Not all of them are related to the business.
Close. Maybe not all of the things located inside of business entity are people. Right? So we keep track of people, employees, customers, whatever else we have. But we also keep track of things that aren't people, like businesses, or government agencies, or school districts, or whatever else we're doing, right? So it's just an interesting piece of data to keep in mind as you're going through, because whenever you guys will, like, hopefully, I mean, if you get a good job, you'll go through, like, 6 months of training before you actually start doing anything in your job. One place where they were going to hire me said that they would have to train me for a year before they'd let me do anything. And my brain was just thinking, I could learn as much as the CEO of the company in a year. I can't imagine having to be trained for a year before I got to do anything. There's not much I can't learn in a year, everything about, if I wanted to. So, anecdotally, it's important for you guys to notice things with databases whenever you go and get a job. So you will get trained one way or another, either trial by fire, or you're going to go through a structured training process where you're going to go to class every day or have a mentor or something like that. Regardless, you're going to have to learn the ins and outs of whatever database system it is that you're going to be dealing in. And so recognizing things like what we just recognized is important to do, just for general knowledge on the structure of the database itself, because you're never going to learn everything, right? Never. Just like you're never going to learn everything about any single programming language that you've ever used. You're just not. That's all there is to it. And they're constantly changing, so. All right, so let's get back to the task at hand. Give the first name, last name of all employees who work in the Human Resources Department. Okay. So what pieces of information do we need to know now? What do you guys want to know next?
I said hire date.
Hire date?
Because I feel like you might
how is, what's a quick way of checking that?
It is not null.
No.
If there is a hire date.
If there is a, but what, no, sorry, I asked the question wrong. What is a faster way of recognizing whether or not every employee has a login? With what we have right now? How can I look to see if every employee in the employee table has a login ID? So those of you online, Angel was saying, hey, maybe some employees are hired, but they don't have a login ID yet. That's a possibility, right?
Where login ID is not null.
Right. Where login ID is not null. So let's go check that really quick. Where employee.login ID is not null. So I get 290. So, I mean, knowing what we know, we can say, oh, well, crap. We know that there's 290 rows inside of the employee table, so it looks like everybody has a login ID, right? Now, one last thing I have to limit on. So now I've got only the employees, but now I want only the employees that work for the Human Resources Department. How do I do that? Come on!
Do we check job title?
Okay, there you go. That's a good suggestion. Let's go look at humanresources.employee and see what we can see. So select job. What is it? Title from humanresources.employee, and let's select. Let's just select distinct, so we only get one inside of there. And there's only 67, right? So we'd have to scroll through these things and figure out, unless there's some, is there some employee, oh, look at this, human resources.department. Uh-oh. Oh, there's a rabbit hole. What do you think department is? Name, group, oh man, I gotta go look at it now, right? So select everything from humanresources.department. I don't even know what's in this table. Let's go look. Oh yeah, here we go. Oh, Snapperilla. So here is a department ID called Human Resources. And department ID is a primary key, which means it's probably used as a foreign key somewhere else. So all we got to do is find where department ID is used, and then we can tie that in, if it's tied, somewhere to somebody at some point. So humanresources.employee doesn't look like it has a department ID inside of there. So where else could we look?
Human resources.employee department history.
Human resources dot employee department history has columns inside. Oh, here we go. Now we've got a business entity ID tied to a department ID, tied to a shift ID, tied to a start date ID. Oh man, that table sounds like it's going to be fun, right? So let's select everything from human resources dot employee department history. Okay, so I get repeated values inside of here. Oh man, we're going down a big old rabbit hole. Yeah, we're out of time. Good job, Jennifer. Before we went down the rabbit hole. So we'll pick up there. We'll pick up there next time. We'll build out this entire thing. On that question, I didn't expect to go this deep, but I like how deep we've gone because this process is a good process. So we're going to go and absolutely do this the next time. We will tie this to department ID, get the latest department for an individual, and I don't know exactly what this means. Oh, that's department ID. Yeah, so anyway, we'll get that done next time, so I'll see you guys then.